From 1983 to 2003, the drift velocity of the North Magnetic Pole increased by 500%, and the movement occurs in one direction. What do scientists think about this? How does this tie up with global climate change? What is the true reason for the ongoing processes? We will find answers to these and other questions in this release.
Global climate change is one of the most important international problems of the 21st century. The overall rapid increase in the dynamics of cataclysms which have been observed in recent decades is particularly alarming. Today, there is a big risk of misunderstanding and underestimation of all the factors and the scale of influence of various cosmic and geological processes on the global climate change on Earth. Just a while ago, at the end of the 20th century, some scientists put forward various hypotheses and theories about gradual climate change. But in practice, everything turned out to be somewhat different. A thorough analysis of the growing number of natural disasters and extreme weather events around the world, as well as statistical factors of cosmic and geophysical parameters in the recent years, has shown a disturbing tendency towards their significant increase over a short period of time. This data indicates that the assumptions which were put forward by a number of scientists about the gradual nature of climate change of the Earth within 100 years and more are incorrect, as in fact this process is much more dynamic.
The Alatra Science Report on the problems and consequences of global climate change on Earth, effective ways to solve these problems. What was said in the 2014 report on the problems and consequences of global climate change on Earth, effective ways to solve these problems, is unfortunately already becoming a sad reality for many people. For more in detail, see the program with the participation of Igor Mikhailovich Danilov, Climate, The Future is Now.
Earth's magnetic field. Enormously rapid shift in the North Magnetic Pole relative to the South Pole of the Earth. These significant changes cause serious problems not only in the failure of navigation equipment, but of other electronics as well. What extreme consequences can this lead to in the near future?
In the middle of January 2019, scientists were forced to update the data of the World Magnetic Model. This model is used to navigate all sea, air and most land transport.
Hello, my name is Vyacheslav, and for the last 15 years I have worked in Australia. I am a sailor, and I want to share my observations of changes of the Earth's magnetic field. Let's start, perhaps with the magnetic compass. The magnetic compass is a must-have equipment, that is, in other words, equipment that should be on every sea or river ship. Every watch that is 6 times a day. The watch officer must calculate the residual deviation of the magnetic compass. The residual deviation of the magnetic compass is, in fact, a constructive correction of the compass itself. The deviation is the deflection of the compass needle from the meridian line under the influence of large masses of iron located near it. Magnetic deviation is an error in indication of a magnetic compass. Once every 5 years, a deviator arrives who conducts, let's say, a series of maintenance procedures, calculates the residual deviation of the compass, draws up certain tables and draws up graphs of the residual deviation. And at a later stage, the assistants simply confirm it, compare their calculations with this data. And it was noticed that the residual deviation is far off from the predicted one. Various factors can affect this. It was initially assumed that perhaps it were some design defects. Ships sailing in rough waters could also have an effect. Many really different things could be the cause. Corrections of the direction finder itself. In general, we double-checked all these points and did not find large deviations there. Actually, a lot of questions arose. Why is this happening? This is not normal. Changes occur with the magnetic field itself. When I got acquainted with the Alatra movement as well as with the projects related to climate change, the information was found that from 1900 to 1980, The Earth's north magnetic pole was practically not moving. The movement was there, but very small, insignificant and linear. This was very easy to predict, and recently the pole drift velocity became 50 kilometers per year. And this fact, of course, explains a lot. And even that point, that scientists were forced to renew the magnetic model of the planet a year earlier. That says a lot. This points to the fact that change rate of the magnetic field intensity itself is so high, and that it's not only causing some health issues for a few people and some minor natural processes, but it also has an effect on the magnetic model, which is at the core of all the navigation systems. That is, beginning from the most elementary that we have in our smartphones, GPS navigators, ending with the most complex systems that is used by civil and military aviation shipping navigation. I would also like to say that we, as humanity, are now facing global trials by global climate changes. And of course, we need to calmly and collectively sit down and decide how we should live further. Continue enmity, rivalries, consumption, dictated by those who makes a profit on it, or finally understand that Earth is one for everyone. If such a situation arises that it will be necessary for someone to leave their home and run away due to the same climate threat, even to another continent, I want to be sure that on the other continent they will be accepted humanely, will receive help and support. But this is only possible if the person himself is ready to accept support and help his neighbour.
Why did the renewal of the world magnetic model happen earlier? The fact is that the North Magnetic Pole has moved for several centuries at a speed of up to 10 kilometers per year. And in recent decades, it has been moving at a speed of about 50 kilometers per year towards Western Siberia. The South Pole, vice versa, is slowing down. Because of the change in the position of the poles, scientists are constantly adjusting navigation models. This happens according to plan. For example, the World Magnetic Model is updated every 5 years. According to the schedule, the model was supposed to be updated at the end of 2019. But at the beginning of the year, they found the error extent exceeded the permissible limits. That is, the North Magnetic Pole has moved so quickly that it exceeded scientists' forecasts. This points to the fact that active processes are taking place in the core of the planet. Here's what scientists say about this.
Elgin Khalilov, a scientist, geophysicist, professor, doctor of geological and mineralogical sciences. Over the past 20 years, the drift velocity of the North Magnetic Pole has increased by more than 500% for the first time over the entire 100-year period of observation. And this velocity has remained almost unchanged persistently until present day. This is not just movement acceleration of the magnetic needle in the compass. The fact is that the geomagnetic field of the Earth is formed as a result of complex energy processes in its inner and outer core. Therefore, if the magnetic pole started moving 5 times faster, then an energy surge has occurred at the core level, and this energy has already erupted in the late 90s. But it has not yet reached the lithosphere. However, its first signs are already manifested in the form of increased seismic and volcanic activity of the Earth. On the other hand, around the same period, namely in 1998, a sharp increase in the number of many natural disasters began. Earthquakes, volcanic eruptions, tsunamis, hurricanes, tornadoes, and so on. When the Earth rotates, a magnetic field arises. This magnetic field interacts with the magnetic field of the Sun. When a colossal outburst of solar matter occurs during coronal mass ejection on the Sun, an electromagnetic wave transfers its energy to the Earth's magnetosphere. In addition, an electromagnetic wave has an influence on electric currents circulating inside the Earth. Some of the rocks have a piezoelectric effect. When exposed to electric current, deformation and expansion begins. This is one of the mechanisms which is causing electrical stresses inside the Earth. In addition, if outbursts occur in the core, heating increases, then the underlying mantle layers also overheat and the convection streams start acting up. All of this leads to tension increase in the bowels of the Earth. Connective streams move lithospheric plates. Alatra scientists have analysed the effects of many natural disasters. They discovered the connection of the magnetic field and seismic activity. For example, before the earthquake in the Japanese Fukushima prefecture in 2011, changes in secular magnetic variations have been observed on the territory of the Japanese archipelago. Also, before the start of seismic activity, anomalies of the Earth's magnetic field had appeared. Researchers from the University of Tokyo have applied machine learning methods to obtain fast and accurate estimates of local geomagnetic fields with use of data obtained from several points, which potentially allow to reveal several changes caused by earthquakes and tsunamis. Scientists have developed and trained using existing data, a deep neural network model, and as a result got a quick, effective method of magnetic fields assessment for early and accurate detection of natural disaster locations. This is vital for effective warning systems development that could help reduce casualties and property damage. It is known that earthquakes and tsunamis are accompanied by local changes in the geomagnetic field. Piezomagnetic effect is typical for earthquake, the occurrence of magnetization under the influence of external pressure. For tsunamis, this is a sudden massive movement of the sea which causes changes in atmospheric pressure. This in line affects the ionosphere, subsequently changing the geomagnetic field. That method allows you to get to know about the tsunami almost at the time of its occurrence, since the electromagnetic waves move at the speed of light and are significantly ahead of the tsunami waves.
Vladimir Valeryevich Kuznetsov, Doctor of Technical Sciences, Professor. In 1860, the magnetic poles stopped their chaotic drift and started moving towards each other along magnetic poles' inversion drift route. The speed of the north magnetic pole is constantly increasing. Contrary-wise, the speed of the south magnetic pole is decreasing. Perhaps this is due to the fact that it has already come close enough to the Antarctic magnetic anomaly, where it should be located until the change of dipole field sign. It is known that the dipole component of the geomagnetic field is constantly decreasing during the entire observation time. These facts may mean that the Earth is on the verge of the beginning of geomagnetic inversion or excursion. Perhaps they have already begun, and as we noted, these events have a huge impact on the climate. Magnetic dipole can be imagined as a system of two magnetic charges, the vectors of which are located opposite to each other. Geomagnetic reversal, in other words polarity change, is a flip of the magnetic pole's position. During magnetic field reverses, the north magnetic pole and the south magnetic pole change places and the compass needle starts pointing in the opposite direction. The poles can slowly return to their former stable position. Such failed reverse, as well as the continuous movement of one geomagnetic, or both poles in one direction, is called an excursion. Typical properties of these events that affect biological objects are the length of the reduced intensity period of the geomagnetic field, an increase in the radiation level, and climate change.
Nikolai Simakov, candidate of Geological and Mineralogical Sciences, senior researcher at the Institute of Oil and Gas Geology and Geophysics of the Siberian branch of the Russian Academy of Sciences. 30 years ago, we published a forecast according to which the true magnetic pole will be located in the Eastern Hemisphere in 200 to 250 years. This was also mentioned in the monograph Physics of the Earth, a new look at some problems published by Novosibirsk Publishing House, Science in 1989. Now the forecast seems to be off speed.
Today we are visiting the Institute of Geophysics, named after Serafim Ivanovich Subotin. Today we will talk to leading researchers of the National Academy of Sciences of Ukraine.
Something is happening all the time on Earth, and first of all, it is what geophysicists are interested in. These are physical fields that are observed on the surface of our planet. These fields show us that our planet is constantly found in some variable situations. Naturally, all these variable situations are accompanied by changes not only in the fields, but also in people's living conditions.
Climate depends on different factors, including space and interior of the Earth. And therefore, we are talking about the Earth's climate system and the processes that occur in it.
The magnetic field of the Earth changes with time. It changes, and along with this, a polarity reversal can happen when the magnetic poles of the Earth change. And it is, to say, catastrophic phenomenon for the Earth, because the radiation that comes from the Sun, if suppose these tags, roughly speaking, they are called auroral belts, will appear not on the territory of the North Pole or close to the North Pole, but at the equator, then all this radiation will affect people who live mainly in this near equatorial part, where the natural conditions are suitable for humans. And this is a very important layer, and the way it's positioned in relation to Earth. Recently, the magnetic field of Earth has been changing very dramatically. It is decreasing. If we take in general, even for the last 50 years, it has decreased by 1,000. If the total field strength or induction on the planet on the average 47,000 nanoteslas, then over the past 50 years it has decreased by more than 1,500 nanoteslas. These are very considerable changes. Moreover, against the background of such a general change, which will lead to the penetration of these particles closer to Earth. This is one of the factors in increasing the warming of Earth. Because if the magnetic field is completely weakened, then most of the cosmic radiation will penetrate directly to the planet, to Earth. So we won't need to sunbathe. We will already be exposed to a strong ultraviolet radiation. Therefore, this is a kind of a bridge to climate, what impact it can have. Magnetic field decreases, and due to this, more energy gets closer to Earth. This is, first of all, but this is what it does. This is the change that can have a bad effect on Earth. But on the other hand, I should say that it is a necessary component of human existence in general, like air, like water, and other things.
The question of the origin of the Earth's magnetic field has not yet been completely answered, albeit most scientists conclude that it is related to the Earth's core. The core consists of a solid inner and liquid outer parts. Scientists believe that the liquid outer core generates electric currents. The release of current flows and the formation of magnetic field occurs as a result of convection in the core. Earth's magnetic field, also known as the geomagnetic field, is an invisible shield that protects our planet's surface from harmful solar radiation and solar wind. The sun constantly emits streams of ionized, higher-energy particles that are dangerous for life on Earth. The magnetic field does not let harmful particles reach the surface of the planet and makes them go around the Earth. If there was no magnetic field, the Earth would resemble a Martian desert. During the days of solar storms, the solar wind intensifies sharply. It causes auroras and geomagnetic storms on Earth. The level of radiation in the ionosphere increases so much that it is dangerous for astronauts to go into open space at this time.
When there is magnetic radiation, some kind of magnetic storm, these rhythms shift. Therefore, it is one of the mechanisms of influence on people. How can it influence? Well, on one hand, the magnetic field is necessary for rhythms to develop. Not only under the influence of the magnetic field and the gravitational one, but also the sum of the fields influences rhythms of our organs. And on the other hand, it is a containment. And then again, if it decreases and does not correspond to some norms, it becomes dangerous for a human being. Not only this rhythmic activity, but especially now, Lately, it is necessary to pay attention to such local conditions. In the cities, it is very much distorted by technogenic factors. In the subway, in shopping malls, in buildings that are currently under construction, especially such as panel monolithic ones. They lead to a very significant distortion of this natural field. And all this should be studied because it all affects not only the general characteristics of some processes on Earth in general, but also at each specific point, which to say determines the conditions of our living. When the geomagnetic field interacts with the solar wind around the Earth, there appears a plasma layer called the magnetosphere. The magnetosphere surrounds Earth in space within 70,000 to 80,000 kilometers towards the Sun, which can be represented as approximately 12 Earth's radii. On the night side, it extends to over several hundred terrestrial radii and forms a magnetic tail. The shape and dimensions of magnetosphere are defined by the magnitude of the Earth's magnetic field and the solar wind pressure. The geomagnetic field penetrates all three spheres of Earth, the lithosphere, hydrosphere and atmosphere. It also has a significant impact on climate and weather. Changes in its intensity can lead to significant variations in temperature, atmospheric pressure and rainfall frequency, as well as storms, hurricanes and other natural disasters. Earth acts as a huge magnet, the south pole of which is located at the geographic North Pole and the North Pole respectively at the South Pole. Actually, geographical and magnetic poles of Earth do not coincide, not only in direction. It is necessary to separately identify geographical and magnetic coordinates because the magnetic field axis is tilted 11.6 degrees from the Earth's rotation axis. Because the difference is not very significant, we can use a compass to determine the direction towards the geographic poles. Compass arrow points exactly to the Earth's south magnetic pole and almost exactly to the geographic North Pole. If the compass had been invented 720,000 years ago, it would have pointed to both the geographic and magnetic North Pole.
Why is it so important to observe the Earth's magnetic field? How does the Earth's magnetic field affect the planetary climate? Let's understand it. Despite the fact that the magnetic field cannot be seen, the inhabitants of Earth feel it well. Migratory birds look for the way, focusing on it. In addition to birds, sea turtles navigate, using the Earth's magnetic field as a form of GPS. After studying, under the Google Earth project, photographs of 8,500 cows in 308 regions of the world, scientists concluded that these animals preferably orientate their bodies from north to south or from south to north. In recent years, there has been more frequent cases of dolphins, long-finned pilot whale, who have thrown themselves ashore in the coastal regions of the Indian and Pacific Oceans. Environmentalists explain this strange phenomenon by the fact that dolphins react to changes in the Earth's magnetic field, which is caused by underground vibrations.
Scientists concluded that plants which are growing freely orientate themselves toward the south magnetic pole. This effect in plants was closely studied in considerable detail, both in natural and artificial conditions. In all cases, plants reacted to changes in the direction of the magnetic field. A person may not feel the influence of a magnetic field, unlike other physiological influences, but the body still reacts to it with functional changes in the nervous, cardiovascular systems and brain activity. The geomagnetic field of the Earth is observed by secular, diurnal and irregular changes, variations, including magnetic storms. Strong perturbations of the magnetic field last for several days. During periods of increased solar activity, the number of charged particles entering the Earth's magnetic field increases. This leads to its perturbation and entails geomagnetic storms. The main types of solar activity leading to storms are solar flares, coronal mass ejections and coronal holes. As a result of this, a large number of charged particles fall into the surrounding space, which fly with the cosmic wind toward the Earth. On average, they reach it on the second or third day. At the moment when they reach our planet, its magnetic field perturbs and a geomagnetic storm sets in. The duration of geomagnetic storms can range from several hours to several days. Researchers have found that the periodicity of geomagnetic storms is directly related to the 11-year cycle of solar activity. During the years of solar maximum, the number of magnetic storms in a year can reach 50, and when the activity of the sun is minimal, only 1 to 2 storms per year may occur. Parameters of the geomagnetic field are continuously measured by observatories around the world, as well as by satellites from space. Today, there are 140 observatories that make up the International Intermagnetic Network. These observatories record the full vector of the magnetic field, as well as its variations. Measurements of the Earth's magnetic field from space were done by the European Swarm satellite system. However, the complete picture of secular changes in the magnetic field cannot be captured, since ground-based measurements are carried out point-wise only on land. Also, holes in the Earth's magnetic field are not taken into account. Peculiar gaps in the magnetosphere penetrated by enormous fluxes of solar radiation. The number of these holes is constantly growing for unknown reasons to science.
Today on the planet, there is a change in the Earth's magnetic field and a drift velocity of the magnetic poles. These are global processes that today mankind is not able to affect. There are 2 processes taking place for the geomagnetic field right now: the rapid movement of the North Magnetic Pole and the weakening of the geomagnetic fields. For many years, the relationship between secular climate changes and the changes in the geomagnetic field is being discussed. In his works, Professor Vladimir Kuznetsov offers a model for the case when a significant decrease in the geomagnetic field occurs on Earth. A model is proposed according to which on the Earth, at the time of excursions, when a significant, almost to zero decrease in the modulus of the geomagnetic field occurs, high-energy particles of the solar wind and galactic cosmic rays, usually deflected by the Earth's magnetic field, passing through the stratosphere, destroy the dust aerosol layer being there, which shields the Earth from the flux of solar radiation in ice ages. The atmosphere becomes transparent, the sun heats the surface of the Earth, which leads to the rapid melting of glaciers and the emergence of global climatic disasters. In a scientific article, Sergei Sergeyevich Tsigankov, co-authored with Evgeny Ivanovich Shemyakin, Changes in the Earth's Magnetic Field, Causes and Possible Consequences, writes, recent measurements of the magnetic field intensity show that the inversion process has already begun. According to observatory observations data, the dipole moment of the Earth's magnetic field is steadily decreasing. According to some estimates, over the past 170 years, the geomagnetic field has weakened by almost 10 to 15%, and over time, the speed of this process increases. Over the past 20 years, from 1980 to the year 2000, new sections of the reverse magnetic field have been formed, in particular, under the eastern coast of North America and the Arctic. In addition, previously identified sections of the reverse field increased and shifted towards the poles. Based on the model, the processes of field blinking, that is the formation of sections with a different polarity caused by a decrease in the tension of the main dynamo, can be considered the first signals indicating the possibility of an imminent global polarity reversal. Occurrences of change in the tension and orientation of the geomagnetic field are evidenced by the occurrences of the mass death of birds, carrier pigeons and others alike, which during flight are guided by the magnetic lines of force and do not find the right path. In any case, it is clear that the process has begun and humans are not able to stop it. Now, it is vital to build a scientific forecast of the process of formation, change, and inversion of the magnetic field, as well as designing a completely new system for protecting human civilization from this previously unseen yet overwhelming force factor in its history for a long period of time. The smallest value of the geomagnetic field falls on the territory of the South Atlantic anomalies. The anomaly extends from Chile to Zimbabwe. In this place, the concentration of cosmic rays reaching the Earth's surface is noticeably higher than other regions. Monitoring of the magnetic field by the swarm satellites confirm its general weakening, as well as the fact that its weakening is most prominent in our planet's western hemisphere. The Alatra Science Report on the problems and consequences of global climate change on Earth, effective ways to solve these problems, considers the issues of Earth's magnetic field weakening. Scientists have come to the conclusion that Earth's magnetic field weakening is a precursor to the growth in intensity and frequency of natural disasters. The change of Earth's magnetic field strength occurs unevenly on the surface, most noticeably in the Western Hemisphere, in particular over North and South America. In 2014, scientists warned that those territories would experience the most severe disasters in the near future. Development of methods for observing Earth's magnetic field, as well as Earth's septonic field, is the subject of primordial Alatra physics. It makes it possible to react in a timely manner to variations in the magnetic field and septonic fields, and to take countermeasures to eliminate or minimize natural disasters. Early identification of the location of future natural hazards, for example earthquakes, volcanic eruptions, tornadoes and hurricanes.
We've been fighting a long time, and we have all lost so very much, so many loved ones gone. But you are not alone. There are pockets of resistance all around the planet. We are at the brink. Above all, stay alive. You have no idea how important you are. This is John Connor. If you're listening to this, you are the resistance. John Connor.